All right, this is Algebra 3, review part 2 for lessons 1 through 20, something like that. Picking it 1 through 16, sorry. Picking back up with question number 4. Let's see. We did finish off, we finished at least all the positive hypotenuse side of everything. Let's see, I don't know if I can, I'm going to end up overhearing myself on the Chromebook, which is going to get real annoying. I don't want to, yeah, you mute it. Okay. All right, so we've got all of the positive hypotenuse side down. Okay, what I'm going to do down here, just to make this easier for us to see, is I'm going to start this over so that we're not looking at two different hypotenuses and different angles all working at the same time. But this is going to be a lot harder if I have to talk over girls in the back. So normally I don't mind, conversation and things like that, but it gets distracting when we're trying to do stuff like this. Okay, so we have our upside down over here. Our angle right here is still 51.12. Okay. All right, this is still going to be distracting. I don't know, am I coming across on somebody else's Chromebook now? Make sure your mic is off so I don't catch that. Is it just mine?
No, those are mine.
Okay. Okay, so we have, this is what we're referring to as our negative our negative hypotenuse. What was our hypotenuse? It was, what, 3.98? Okay, so we've got negative 3.98 and negative 3.98. Okay, so if we want the positive degree to the negative hypotenuse, which direction do we go? From the initial side, which is right here, am I going clockwise around to my green line, or am I going counterclockwise from the blue to the green line? Counter is going to take me in a positive degree, which is really easy in this case because we already know what it is, right? Because it's the same as the reference angle, which is what? 51.12. Okay, because we already knew what this was. We knew that was 51.12, okay, because that's what our reference angle was on the opposite. Okay? Does that make sense to us? Do we understand that part of it? Okay, now if I want the negative, which direction do I go? Clockwise, so I'm going to go all the way around. And so how do I do the math to figure out how many degrees I've gone?
360.
Okay, 360 minus 51.12, because we're only 51.12 degrees from making a complete circle. Okay, what's 360 minus 51.12? That's what calculators are for, right? 308.88. Okay, now the really easy mistake to make here is to leave off what? The negative. It's negative only because we're going clockwise. Okay, so the math doesn't show the negative, but I have to. 308.88 negative degrees. Okay, so I have this for my negative hypotenuse, and I have this up here for the positive hypotenuse. Okay, it's a ton of work. Okay, but you may not do this question now, but these questions aren't going to disappear off of your tests. They're going to keep showing up. So the more you get familiar with it, you might not do it on this test, but you might get to a point where the questions that are hard on this test are the easy questions on a test down the road. Okay, so if you keep avoiding these questions, they're not ever going to get any easier, and eventually you're going to get to a position where all that's left are hard questions. Okay? All right, so I think we're ready for the next question, which for us is number 8. And give me a second while I pull that out. And I don't have that book. Now, I don't know how many of you noticed on Classroom. Did anybody look at Classroom this morning? Okay, what did you notice in the Classroom this morning? I posted everything, right? Like everything for all of next week, including the review. All right. So let's see, we're on test 4B, we're on question number 8. Okay, it says solve for D. Let me, and again, we're solve for D. Okay. Again, there's more than one way to solve these questions. Emily, can you see this okay? Okay. All right. The way I begin with this is I begin by distributing the R to the numerators. So I get y equals rbx over c plus ra over d. Okay? So step 1, distribute. Step 2, what do we think it's going to be? Common denominator. Common denominator. So what do I have to do the first fraction to get a common denominator? D over D. Okay, what about on the second one? C over C. So I have y equals drbx plus rac all over cd. Okay? Does that make sense so far? Okay? So we got a common denominator. We distributed our variables out, set it all over the common denominator. What's the next step? Multiply by the denominator. Okay, multiply by CD over here as well. Okay, so we get CDY equals DRBX plus RAC. All right, now this is where knowing what we're solving for comes into play. Okay, because I'm going to move one of those two terms to the other side, but knowing what I'm solving for will determine which term I move. I'm going to move the first one. Why am I moving the first one? Right, because the second term doesn't have a D. So how do I move it over there though? By subtracting it because it is positive. Okay, and okay, minus drbx minus drbx from both sides. Okay, so what am I going to write to show that being done? CDY minus drbx, what does that equal? Equals RAC. Okay, what's the next step? Factor out the D. All right, it's like I got RoboCop helping me out here. Factor out the D. It's like, thanks, Batman. All right, factor out the D. All right, so we take the D out, and then what am I left with in the first term? CY. CY minus RBX equals RAC. That's like if Bruce Wayne had gone a different direction in life. I could fight crime, or I could teach Algebra 3. Use math to save the world instead of my punches. Okay, what do we want to do lastly? Divide by CY minus RBX. Okay, so finally, D equals that solution, RAC over CY minus RBX. I understand. Riddle me this. Okay. You need me to hold up? Okay. We're good to go? Awesome. Awesome. This is what, number 8? We're ready for number 9. Numero nuevo? I don't know. Nueve. All right. Okay. Let's see. And we got 4 radical 2 minus 3. All right. First step. Multiply by the conjugate. Okay, what is the conjugate? 4 radical 2 plus 3 over 4 radical 2 plus 3. Okay? Second step. FOIL. Okay? FOIL. 1 times 4 radical 2. 4 radical 2. Okay, that's first. Outer. 1 times 3 plus 3. First outer, inner. This is where things get complicated. All right. All right. So I'm going to put over here just so we see everything that's happening. 3 radical 2 times 4 radical 2 is 12 times radical 4. 12, or because radical 2 times radical 2 is radical 4. All right. And radical 4 is 2, and 12 times 2 is 24. All right, so do we understand everything that took place there all at once? But it took kind of several steps. So we have 4 radical 2 plus 3 plus 24. Okay? And then we have 3 radical 2 times 3 plus 9 radical 2. Okay, and before we move away from that, let's go ahead and combine like terms. So I get what, like 27 plus 36. We're not multiplying. It's 4 radical 2 plus 9 radical 2. 27. 3 and 24 are like terms. 4 radical 2 and 9 radical 2 are like terms. Okay, does that make sense? All right, so this is my numerator. We're going to hold on to that, keep it separate, come back to it later, okay? All right. The denominator. All right. You FOIL, but notice that the denominator FOIL is always a sum difference, right? So do I ever need to do the IO or OI, the outer inner? No, because they are always going to do what? They're always going to cancel out. So all I really need to do is 4 radical 2 times 4 radical 2 and negative 3 times positive 3. So 4 radical 2 times 4 radical 2, what's 4 times 4? 16 times radical 4, 16 times 2, 32. Okay, so I have 32, and then I have negative 3 times positive 3 is negative 9. 32 minus 9 is 21. Oh, I'm sorry, 23, right? 23. All right, so you're confused? All right, 32 minus 9, because 4 radical 2 times 4 radical 2 was 32, right? 3 times, or negative 3 times 3 is 9. This this number alone is my denominator. All right, then finally, we have 27 plus 13 radical 2 all over 23. Did somebody just say they were lost? Did I lose somebody? Okay, I must have overheard incorrectly then. It doesn't, because 13 is a prime number, I know right off the bat, this isn't going to simplify, right? That not everything's divisible by the same thing. So if I'm not mistaken, I believe that this is your final answer. And you guys still have the answer key from the other day. Okay? We're all good there? All right. 9, let's see, we need 14. And Emily, if you have questions, just go ahead and chime in. Or don't, it's whatever. All right, we got radical 6, radical 3, radical negative 6, radical negative 3, minus radical 6. I can already tell I'm going to run out of space. Radical 3i, radical 6, radical 3i cubed, minus radical negative 36. So what I like to do with these is simplify them by term. Okay, so this block, I want to work with just that block for now. Okay? Are you with me? Okay. So let's see. First off, what's the easiest thing to do with that? Take out the i's. Okay? Which coincidentally is the same thing in torturing. It's the easiest first thing to do. Just take out the i's. All right. I radical 6 and I radical 3. Okay? Now, what is being done between every one of those terms? Multiplication, multiplication, multiplication. Okay? So radical 6 times radical 6. What is that? 6. Okay? And radical 3, here, let's show what's being done here. Radical 6 times radical 6 is 6. Right? Radical 3 times radical 3 is 3. So times 3. And then we have I times I. All right, which is I squared. We might as well just show every step. I squared can be written as, okay, times negative 1. So I have 6 times 3 times negative 1, which is negative 18. We're all good with that, right? Yeah. All right. So notice how if we take everything one step at a time, we're less likely to make mistakes than trying to do too much at once and then losing a negative, losing something along the way. Because most of the time on a question like this, you got the wrong answer on review day, you notice, because something small happened, right? Okay? So we're trying to eliminate small mistakes. All right, let's move on to this section here. Okay? Now, I'm going to go ahead and take that negative, and I'm going to slide it down here, so I don't have to worry about it. Is that good with you guys? Yeah. Okay, so we're just going to treat this, as radical 6 times radical 3i times radical 6 times radical 3i cubed. All right, so all the negatives have already been taken out, correct? Yeah. Okay, so can we go ahead and do radical 6 times radical 6? 6, and can we do radical 3 times radical 3? 3. And now I have 4 i's. I got I, and I. Why do I break them up into sets of 2? Because I equals negative 1, so 6 times 3 times negative 1 times negative 1. Negative 1 and negative 1 do not cancel, but they become positive 1. 6 times 3 times 1 is 18. But notice what we're doing here because I brought that negative down. It's still minus 18. Right? All right. Now I'm going to take this negative and I'm going to bring it down here. All right? So that I don't lose it or forget it. All right? Now, what's the first thing I want to do with radical negative 36? Take out the I. Okay? So that's radical 36i. What is the square root of 36? 6. So I have 6i. Can that be simplified any further? So I have minus 6i. What happens? Okay, so I got negative 18 minus 18. negative 36 minus 6i. I've got it in order. That should be my final answer. I don't know what's in the answer key, but hopefully that. Okay, are we good? All righty then. It's number 6. Simplify. Okay, we got 2x to the 3 halves minus 3y to the 5 halves times 2x to the 3 halves plus 3y to the 5 halves. What do we notice about those two things? It's a sum difference. So I can just simply FL, right? FOIL without the O and the I. Okay? So, but I need to know something about what's going to happen with the exponents. What's 2 times 2? 4, so that's fine. What do I do with those exponents? Add them. So I'm going to get 3 halves plus 3 halves, which is, what is 6 halves? 3. So if I have to, let's say 3 halves plus 3 halves equals 6 halves, okay, which is equal to 3, so I get 4x cubed. Okay, does that math make sense? Okay, now we're just doing this set right here, so we don't have to do any extra work. What's negative 3 times 3? Negative 9. And I'm doing 5 halves plus 5 halves is 10 halves, which is equal to 5, right? So 9y, negative 9y to the 5th. Is that the correct answer? If it's a sum difference, I don't have to do O and I, because I've got subtraction and addition of the exact same things. That's the only time that sum difference works, though, is it has to be exact, with the only exception being plus in one and minus in the other. Okay? And it wouldn't matter if plus was on the left and minus was on the right, it would still be a sum difference. Okay? Is that easier than what we were making it? Okay. 7. Okay. So this is this is RREF. All right? But notice in the first one there's no x. So 0. 1/4, negative 2/5, 1/10. Okay? Are we okay? I don't think there's anything I'm doing that's terribly hilarious. All right? Now, you can type it in as I guess 0.5. Okay? And then notice that there's no y though, so we have to put in a 0. And then 0.5 z and 2.5 solution set. Okay? The next set has an x. You could type it in as 3/4 or 0.75. There is a y, but there's no z. Okay? So that's the order. Okay? If it helps so that we see that, okay, and I'm going to RREF a 3x4 matrix, okay, to solve. And because it's XYZ, I should get, my answers are going to be over here, and it's going to be X, Y, Z down through there, and it'll probably show itself where we look at all of this, and I get what 1 0 0 0 1 0 0 0 1, and then these 3 numbers are going to be X, Y, and Z. Um, do I need to work that out in a graphing calculator for you? You got a bunch of decimal answers. Okay, let me take a look at the actual answer key on this just to see what's coming out. 4B, this is what, question 7. You should get 3 whole numbers. And it doesn't come out to 3 whole numbers? Okay. Let me I'm wondering on this, let's see. All right, so I think one of the things that they do in solving this is they get rid of all of the fractions. So like the common denominator, I don't know if you can get 10. It might have to be 40. So yeah, it would be 20. So 0 times 20 is 0. 1/4 times 20. So we're multiplying by 20 here on this row. Okay, so you got 20 divided by 4 is 5. 20 times -2 is -40. -40 divided by 5 is -8. And 20 times 1 is 20 divided by 10 is 2. Right? All right, now I have half, 0, half, 2.5. I should be able to, can I multiply each of those by 2? No, because it's 1/2. So my fractions are 2's. So I should be able to, I might be able to multiply by 2, because 1/2 times 2 is 1. So 1, 0, 1, and 5. Okay? 3/4, I got 3/4 and 2, so I should be able to multiply by 4. So I have 12 divided by 4 is 3. 5 times 4 is 20. 20 divided by 2. 20 divided by 2 is 10. 0. And 8 times 4 is what? 32. So try doing your RREF with that 3x4 matrix and see if you don't come out to 3 whole numbers. You got it right with this? All right, so it worked. It should, and that's what I thought. I thought it should have worked either way, but you should get x equals 4, y equals 2, z equals 1. X equals 4, y equals 2, z equals 1. What's going on? Well, we're laughing about something. I'm not looking at you. I'm looking at Omar and Kathleen. What's going on? Nothing? Okay. Well, if we could do nothing a little quieter, that would be just fantastic. All right. We're ready for 11? All right. All right, number 11 looks like a proof. All right, so they give you a picture. And really, I'll be honest, I don't know, how many of you have had geometry? 2, 3, 3. Cassie's just getting into it. So the 3 that have already had it, I think that the Algebra 3 proofs are a ton easier than the geometry proofs. Okay? So let's see, our given here. So let's start off with we got our statement, we got our reason. Okay, our first statement is DA is the angle bisector, okay? It's the angle bisector of BDC. All right, that's a given. Let's go ahead and write some things up here. I got B, A, C, and D. So what they tell me is that DA is bisecting BDC, this right here. Okay? So before I list the other given, what I'm probably going to say is that angle BDA is congruent to angle CDA. And my reasoning is this: an angle bisector divides an angle into two congruent angles. Okay, I have to say that. I can't just, say BDA is congruent to CDA without drawing from that first given. Does that make sense? And that's where a lot of people mess up, is they think, well, we just know this. Well, we have, a proof is like explaining Algebra 3 to a fourth grader. Okay? My justifications have to go every step through the way. Okay? All right. Then the next thing that they tell you is that BD is congruent to CD. BD is congruent to CD. Now, that's a given, right? They gave me that information. Now I have to look at this. It says write a two-column proof that BA is equal to CA. So what I have to do first is prove that the two triangles are congruent to each other, and then I can prove that their individual parts are congruent to the corresponding parts. Okay? I only have one piece left to prove that the two triangles are congruent. Does anybody know what piece that is? What's that? No, that would be proving that the two triangles are congruent. I need one more piece before I can say that the triangles are congruent. AD. Who said that? All right. AD. Right. AD is congruent to AD. What's the reason for that? Reflexive axiom. Okay. So now I can say that the triangles are congruent. So I can say that triangle BDA is congruent to triangle CDA using what? I think somebody said it earlier. It was just too early. Side angle side. Yeah, I think Omar said it. Side angle side congruency postulate. Okay? Side, side, angle, angle, side, side. Okay, but we're not done yet. A lot of times we get so caught up in proving that the triangles are congruent that we forget what it is that we're trying to prove. We're trying to prove that BA is congruent to CA. Does anybody know how we know that BA is congruent to CA? What's the reason? Corresponding parts of congruent triangles are congruent. CPCTC. All right, let me make this very, very, very clear, okay? You cannot use CPCTC until you have actually proven that the two triangles are congruent. So if you see two triangles and it says we want to prove that these two parts are congruent, one, I know that I have to prove that the triangles are congruent. And my last step is always going to be CPCTC. That's the order. I can never use CPCTC before I've proven that two triangles are congruent. Okay? Because the whole premise of CPCTC is corresponding parts of congruent triangles are congruent. Well, I can't use that until I have first a congruency statement. I can already tell right now that I'm going to get nobody do question number 11 on the test. That's probably not. But we've seen it, we've practiced it, because like I said before, the hard questions on this test will eventually become the easiest questions down the road. That doesn't mean that they're going to be easy, but they're going to be easier than some of the other questions. So the more we start to practice with these things now, the better off we'll be. Number 15. All right. All right, this should be really easy. Is that 95? All right, so a couple of things. This point right here is not central. Okay, it's not in the center of the circle, right? But what do I know about vertical angles? They're congruent. So I know x has to equal x, but the problem is because it's not central, x can't equal 120, right? So a central angle equals its intercepted arc, right? But x isn't central. And if I said x equals 120, then I'd have to say that this x over on the other side equals 120, but its intercepted arc is 70, right? So what x is, whenever it's anywhere other than in the center of the circle, it becomes the average of the two intercepted arcs. The average, which is why I take 120 plus 70, divide by 2, and get 95. Was that the answer in the book, or in the answer key? Check it for me. Yeah. Okay. So do we see how much easier this is than maybe what we made it? Just find the average. The average of the intercepted arcs is my answer. Now I am going to ask, even though I may not be a super big stickler, put the degree symbol on it. Okay? Let's make sure that we're doing a good job at labeling. All right, number 1. These early word problems. Although I am glad to see that some of these early word problems are moving their way towards the bottom of the list. Okay? 1. In a mixture of copper and zinc, 700 tons of copper were required to make 1,010 tons of the mixture. How much zinc was required to make 1,818 tons of the mixture? All right? Anybody get this right? All right? Okay, so zinc. Zinc. In a mixture of copper and zinc, 700 tons of copper were required to make 1,010 tons of the mixture. Right, so 1,010 minus 700, hold on, equals 310. Okay, but we're not done yet. Okay, because we have zinc over 1,010 equals zinc, so if we call this zinc 1, this would be zinc 2 over 1818. Okay, now we have a little bit of substituting to do because this 310 is my zinc 1. So 310 over 1,010 equals the amount of zinc that we needed to make 1,818. Does that make sense? Okay, so from here we're cross multiplying. We'll get some rather large numbers. Okay, but I know we're going to get 1,010Z equals whatever 310 times 1818 is, which is 563,580. Okay, divide that by 1,010. Yeah, it should be 558 tons. Tons. Yep, because everything's done in tons here. Okay? Are we good with that? Okay. In a mixture of zinc, 700 tons of copper were used to make 1,010. Yeah. Yeah. So that's going to tell you how much zinc you need. Okay? So it's just setting up that proportion. All right? After 1 is 2. 2, an airplane. Oh, I think I like these. All right. We got an airplane. Let's okay. Here's an airplane. An airplane has a line of sight that goes out like that. Okay? An airplane is flying at an altitude of 60 feet above the ground. Okay, so he's not very far above the ground. Huh? We got a sleeper? Hey. All right. All right, so he's 60 feet above the ground. Okay. 60 feet above the ground, the pilot spots an object on the ground at an angle of depression. So he's spotting it down here. Okay? Does that make sense? The object, will... I don't know. Yeah. Spots an apple on the ground. Whatever it is. It was going to be a bunny rabbit at first, but that's all right. All right. It says, what is the slant range? Okay. So we have 30 degrees here, and we're looking for the slant range. That right there. We want to know how far he is at a slant from what we need to see. Okay? So we have a right triangle. We have a degree. What do we use? What do I have and what do I use? All right, yeah, it's a 30, 60, 90, and you can use that. You know that this is going to be 60 degrees. But I'm going to say this. What if the triangle isn't a 30, 60, 90 on the test? All right, so I hear this. I heard sine 30. Sine 30 degrees. Because we have opposite over hypotenuse. 60 degrees is opposite of 30. And we're looking for the hypotenuse. So we would multiply by s and s. So I got s times sine 30 equals 60. And then I'm going to divide by sine 30 on both sides. Now, what do I need to make sure of before I divide by sine 30? Make sure your calculator is in degree mode. What's 60 divided by sine 30? 120 feet. Feet. Yep. Okay. Let's see. That was 2. 5. I'm running out of time here, so 5. We got -4, -330. We want rectangular coordinates. So I'm going to take the lead on this. All right. -4 is my hypotenuse. Okay. 330. That's clockwise degrees, correct? Hey, guys, don't have enough time. Okay. So that's bringing me around here. 330 degrees, which means my reference angle is 30 degrees, right? Yes? And my hypotenuse is -4. But it's asking for the rectangular coordinates, and it's not referring to the -4. It's always going to want the right side up. So we come over here, where this is 30 degrees, and this is +4. And now I need the rectangular coordinates, which means I need x, which is going to be negative, and y, which is going to be positive. Okay, now, yes, in this case, you could use 30, 60, 90. But again, what if they don't give you something nice and neat like a 45 or a 30 or a 60? Okay, I would have to use trig functions. Okay, so to solve for y, I would use sine. So I'd use sine 30 equals opposite over hypotenuse, y over 4. Multiply by 4, multiply by 4. Or I'm sorry, yeah, just multiply by 4. Okay, so that's going to give it to you. 4 sine 30. What is 4 sine 30? What? 2? 2. Right? And these should come out to nice, neat numbers. Now for the cosine, or sorry, for x, I'm going to use cosine. So I can take that and just write 4 cosine 30 and get x. But keep in mind, my x has to be what?
Negative.
Negative. What is that? It should be 2 radical 3, correct? Or something equivalent to it, except I'm going to get -2 radical 3 I plus 2j, because it wants it in rectangular coordinate form. Okay? All right, we missed about 1, 2, 3, 4, 5 of the least questions. I will send out this video and any other videos I have along with this document for you guys to study for your test tomorrow. Thank you, and have a good day.